laid out as a European layout, which is a European continent, with Paris, Milan, Genoa, Dublin. It's all there, except the contrast is really bad, so you can't see the outline of the European continent, unfortunately. So what we have here on this UI is at the top left, we have the three instances of ONOS, the blue, the turquoise, and the red. And under that, there are each of the IPs of each of the controllers, as well as the number of switches that they're controlling. And
looking for the.
Sure we can do that?
Yeah. Look it up.
That's going to help you with that. Anyway, and on the top right, we have kind of a summary of ONOS that says what version we're running, 1.7, number of devices, number of links, hosts, number of topologies. We only have one topology, so it's a strongly connected topology. Number of intents, tunnels, and flows that are installed.
This is just a simulation of the GEON topology and long-term topology that we are running on Mininet. Basically, what you're seeing here is three machines running ONOS. That's ONOS 10.128.201, 203. Those are the three machines running ONOS. Plus, we have a fourth machine that we are running Mininet on to simulate the network. Just because this is perfect for testing. If we screw up this, nothing happens. If we screw up in production, that's the worst thing.
So Andrea is now going to restart the demo, apparently.
No.
Oh, so he just took down one instance of ONOS.
The 203 one.
Yeah. So the one on the right is down, and now if you look, the number of switches under the blue one, the first and the second one has changed, which means that the other ONOS instances have taken control of the switches that went down, and actually the color coding of the switches is only blue and turquoise. The red ONOS has now come back. So if we equalize
it has to start up. There's a little bit of time to start up, and then it will automatically
equalize
the masters. I have the mastership load balancing application app too.
Okay, so anyway, so we can move on then, we'll equalize it.
Yeah, basically what will happen is that when the 203 instance comes up again, we have an application that rebalances the mastership of all the devices to 10, 10, and 10. Okay. So what I'm going to do now is go to the first instance of ONOS and show you some CLI. This is the CLI that we have, and you can do commands through CLI here. And what I'm going to do is push some random intents throughout all the network to showcase the path computation and all of that.
So this command basically installs 300 random host-to-host intents into the system. We can light them up, and we see them all, so they're kind of everywhere at this point. So you can select like two hosts and just show the related intents. That's fine. Move some further away.
Oh, okay.
Yeah, so we get more multipassing. Okay. So between these two hosts, there are these. The intent for these two hosts is installed, and we can just start like firing traffic.
Yes.
Okay.
The green over there. Fairly close to me.
Okay. It's also hard to see, but I guess this is better. Yeah, this is better. You see those little labels show up with the amount of traffic that those links are carrying. Why don't we kill an ONOS instance that's
I can kill
the blue guy, the blue one? Why don't you kill that guy?
Oh, I can kill. No, I can show you something better. I can kill Geneva and show the traffic we route.
Oh, okay, let's do that. wanted to kill an ONOS instance first, but since you want to kill a switch, fine. It depends on the degree of violence you want to do to our network. No, it's just. Okay, so he's taken down the switch, and we see that it vaporizes from the middle. It's all gone, and ONOS just reroutes the intent away from the destroyed area. So what we can do is now can we kill ONOS controller? Yeah, let's kill
2 or 3.
Yeah, 2 or 3 sounds like a good idea. Yeah, we'll kill 2 or 3 because it's controlling 3 hops on the path. Why not kill it? And you'll see that the other ONOS take over, and the traffic keeps on flowing because there was already flow rules already installed, so nothing had to happen, nothing had to change. But ONOS is there. So now, if we were to let it work, I'm trying to see if there's an alternative path to between those 2 hosts. I don't
can go to Luxembourg.
Oh yeah, so kill Frankfurt.
Yeah,
kill Frankfurt, and so we'll take down Frankfurt. So what we've done is we've killed the switch, we've routed around that, killed the controller, we've rebalanced, and now we're going to kill another. It's kind of like a cataclysm happening to our network, right? Like everything is melting away.
Just don't kill Turing.
Kill Turing next. No. Yeah, right? So we killed that, and it's going to reroute it the other way. Okay. So our path calculation engine doesn't assign each hop is 1, right? So it just assigns 1 to each hop. So this is equal to going through Luxembourg from its point of view. If we had distance-based,
but you can assign a weight to a link to specify that that link is more weighted in your topology, so avoid it if rerouting happens.
Anything else, Rachel?
Just a few applications. To do all this, we basically needed a master load balancing application to reload the switches on ONOS.
Why don't you show the list of applications?
Yes, exactly. That's what
Show that.
So these are the applications that are running on ONOS.
Well,
the top.
Yeah. So the ones with the green little check mark are the ones that are running on ONOS, and the remainder are the ones that are installed on ONOS. So if we wanted to activate one, I don't know, pick one application that you want to activate, whichever, doesn't really matter.
Whatever.
Yeah, that'll do. You can just hit play, and it'll activate the application on ONOS, and now the app is active.
And since this application brings new elements into the GUI, you have to reload the GUI because you're bringing dynamic code not only into the ONOS instances that are running, but also on the JavaScript side of the graphic user interface. For example, this brought in the alarms. Right now, there are no alarms on the network, but if we'll receive some alarms, those alarms will show up here. And if you go into ONOS, just to show you some CLI also, not only the graphic user interface, that's more easy to use. For example, if you want to know all the applications that are running on ONOS, you just type. This is the running and active applications. And you can see that to do all of this, we use the host provider to discover hosts, the OpenFlow base to do, the OpenFlow base to do OpenFlow. We have the full management application here that we just activated. We have the default drivers that ONOS activates for OpenFlow devices. We have the host mobility application to discover the hosts and proxy ARP. And this is what we run here. And if we were to activate another application, it just shows up here. And you can also deactivate application. You can do it via CLI, via GUI, and you can also push the whole code of a new application via REST or dropping it into the CLI. Or something else.
No, I think that's good.
If you have any questions, something else.
No
questions. Okay.
Just a small one. Just help. I'll speak up anyway. No, I was it looked like a normal operating system. I guess that ONOS works with a bootstrap, so you can decide a number of bootstrap parameters, like what applications to start up. And,
Yes.
and well, all the
all the usual.
environmental variables that are associated with an OS.
Yes.
Of course,
Yes.
from a network, from a computer OS, from a PC OS to a network OS, right?
In the interest of time, I didn't show this, but this is how you basically set up a 3-cell from scratch, completely pushing the bits into ONOS. You just have Linux installed, you push the bits, and this is how you set it up.
So,
And for example, here I specified that these applications should be started with each instance, and we check that that requirement is done before going on to the next step.
so ONOS has a notion of cells. These cells are kind of like a. That notion of cells basically defines where the ONOS instances are, what applications they should run. But the cell is really something that's a kind of useful to use for development. It's not very useful for deploying. You can deploy ONOS as a Debian package or as a tarball. You just unroll it and ignite it. You can also just download it as Docker and just download a bunch of Docker containers, run them, and then tell them that they're part of the same cluster and then they form a cluster together. So you have many ways of how to deploy it and tell which apps to run. That's up to you.
It's basically up to configuration.
You can feed it, like in the case of Docker, you can feed it an environment variable, which is the ONOS apps variable with a comma separated list of applications that it should ignite with.
Yes.
Thanks.
Another question. Oh,
There's two.
I don't know if you wanted first.
I think he was first.
Okay, I am Michał from Cisnet and from the Jerry Sobieski team. I want to ask about the connections you presented before. What is the path computing algorithm behind that?
It's just Dijkstra.
Yeah.
Just Dijkstra first back then.
Yeah, it's based on what? On just a sorted path or yeah?
Number of hops.
Okay.
It's customizable, so you can assign weights to the links.
And it's some internal service of ONOS?
It's called the path service.
Path service, and you can also have disjoint paths and paths based on geographical data that you basically have. Probably can show you. Basically, this is an overlay that is an application brings an overlay. Basically, select the source and select the destination. And this is the shortest path. You can go to the disjoint path. And in this case, you see it comes with 2 paths. And you can also see, this is just querying the path computational element and asking which are the paths. And this is the geographical shortest path between 2 points. And you can do this between hosts, between the switches, and between whatever you want. And you can also circle through paths with arrows. See, this is a different path than was highlighting before. Okay.
And for example, when I will have an application creating layer 2 circuits over the network, and I want to choose path based on some concrete parameters related with that kind of service, I can query this service for some shortest path and then do my own computing based on other parameters, or this service is capable to handle different parameters as well.
You can give it a weight function.
Basically,
It's Dijkstra. You know how Dijkstra works, right? Dijkstra takes a weight, so you can give it the weighting function, and you can feed in whatever parameters you want there, and they'll take them into account. You're just a lambda.
but if you want, you can compute your own path with your own parameters and then just feed it into the network, bypassing basically our path computation.
Yeah, okay, thank you.
Hi, it's Manuel Paul from Deutsche Telekom. Just a quick one then. Also, probably a popular question: is there anything that you've done like regarding scalability, like some simulation or testing, like with regards to the implementation?
So in the interest of time, we skipped the performance section of the presentation because we're running kind of late. But if you go to our wiki, you'll find a white paper about our performance and scalability. And for performance, scalability, and these things, it depends what metrics you're after, right? So it's a long conversation, but I mean, an ONOS instance can handle, let's say, in the usual case, about 500 switches, roughly, depending on how many ports they have, how many links there are in the network, and then we can push up to 3 million flows per second. Again, that depends how if you have a 7-node cluster that's installing from every instance of the controller to every instance of the controller, essentially. Then things are a little slower, but again, these things are marginal. Roughly, we can sustain about between 1 to 3 billion flows of operations per second. You tell me what scalability numbers you're interested in, and I'll tell you if we have a number for it.
There's a whole white paper.
Yeah,
it's pretty long, and you can go through it and read whatever you're interested in.
So it's a tough conversation because everybody's scalability numbers and performance and benchmarks are different. So we kind of hope that people do their own evaluations and they tell us that didn't work, and we say, okay, that's interesting, let's figure that out.
Okay, thanks.
Yeah, so we should do the last question.
Yeah, I think there were 2 questions, and that's it, because we want to pass to the core part of the presentations.
Are the controllers always supposed to be fully connected to each other? You can have a scenario in which the controllers are not connected.
So no, they need to be connected to each other. Kind of all the controllers connected to every single one. If you have a split brain, essentially, where like 2 controllers are on one side and one is on the other, then things start getting a little hairy. But essentially, the majority always wins. So if you have a split brain and there's more than that will work with. But you cannot have, by configuration, 2 controls talking to each other and one not talking to. It just doesn't work.
You can do that through peering of ONOS clusters, and tomorrow some people from Creative will present that project.
That's not okay. Yeah, sure.
I have an additional question. Do you also study some mechanism to make the controller connect in band, or you think we should still stay to the out of band connection between the controller?
From ONOS's perspective, you can connect in band or out of band. That's up to you. It depends also on your hardware if they support in band control. Some hardware just don't support it. Others have magical rules that are hidden from you that forward basically open flow traffic to the controller. It depends, but from ONOS's perspective, an open flow connection is an open flow connection. Is an open flow.
Okay, if anybody's interested in other ONOS related questions, you can find us in the room and later and whatever during lunch and all of that.
What happens tomorrow? Oh.
We skipped over performance and deployments in the interest of time. So if somebody's interested, that's it. Thanks everybody.
Slides already up there. Can we have the next presentation, please? Nope, that's not it. The other one, the cord one. Someone is running around up there. Okay. Okay, cool. So I'm going to start talking about CORD, Central Office Re-architected as a Data Center. How many people here have tried the first release of CORD? Downloaded it, tried to install it, failed, shouted at it. And a few people. Cool. Good. Happy. So CORD is it's a service provider driven project. We have several service providers: AT&T, China Unicom, SKT, Verizon, NTT, and should add this list. Google as well is a partner in helping us drive CORD. And CORD has 3 use cases: residential, mobile, and the enterprise use case. Mark will talk about the enterprise use case, and then we have a video for mobile CORD. This is kind of a list of collaborators, of people who help us build CORD, who provide hardware, who provide technical support, who provide VNFs in some cases. Your name could be here if you wanted to. So CORD aims to deliver the economics of a data center. The idea is to build infrastructure with commodity building blocks and open source software and white box switches, and provide the agility of a cloud provider. So you want to be able to launch new services easily and rapidly, kind of like the Facebooks and Googles of today, and Amazon, and so on. So in this slide deck, I'm going to give you an introduction to CORD. I'm going to touch on how we do service composition in CORD, and then I'll talk about some of the ONOS-based services that are in CORD. So the idea behind CORD is we took SDN, NFV, and the cloud, and we kind of like put them all together, and we defined a little area in the middle as everything as a service, which maps to our orchestrator, which is called XOS, which is everything as a service operating system. Kind of gets a bit long, but that's the way it is. So the idea is we want to take the kind of like microservice paradigm and put it closer to the edge of the network, where you want to be able to run services maybe at the edge, not necessarily with a whole bunch of compute, but just closer to the edge so you can have better turnaround times, better quality experience for your users. Then of course we want to use SDN to interconnect VNFs, the usual canonical case, and NFV to bring in VNFs and legacy VNFs and support them, and potentially also disaggregate previous equipment like this is, for example, a VRAS or whatever we want to disaggregate it. So why did we decide to try and do this? So how many of you here have, I'm sure a lot of people here have been into a central office, right? So a whole bunch of you have been into a central office. It's kind of a silly question for this location. But anyway, so you know that a central office is kind of like this museum of computer science where you kind of walk around and you see like a whole bunch of equipment that like is dated, and all that equipment has its own management interface. It has super high capex and opex. It's just very complicated to manage, and it just adds to the complexity of operating the network. And so the idea here is to move away from that infrastructure and commoditize kind of this hardware here. So the idea would be to build this on kind of the core architecture, a data center architecture, where we have a leaf spine fabric, which is the number. We have a leaf spine fabric, which is sitting up there, and then the switches, and then the regular commodity compute, and then we have the access of CORD, and the egress part of CORD, which could be packet, which could be optical. It depends on your use case. And then, so for example, we use an OLT. It's the AT&T Open GPON. It's a 48 PON port OLT. Fits into one rack unit. it can serve about 3,000 subscribers in one RU, which is pretty impressive. This is just a pod that we have at the at ON Lab. We have about 3 pods like this, plus other pods spread out at our partner locations. We have a lease line fabric, 2 spines, 4 leaves, 3 compute nodes, a couple of LTs, and a few head nodes. And actually, right now, the head nodes and the compute nodes are distinct, but in the future, there will be no difference between a head node and a compute node. And we're basically there. We just need to need some cleaning up, but basically we're there. So the nice thing about Cord is that the sizing is configurable. We can go from partial rack, from half a rack. You can even go down to 1 switch, 1 compute node, 1 head node, and call it Cord, and you're still good. Or you can have a you can go up to 16 racks where you can serve about, if my memory doesn't fail me, about 500,000 subscribers out of 16 racks worth of Cord. At least that's the calculation that we've done on paper. We've never deployed 16 racks worth of Cord yet. So this is the Open GPON OLT. For those of you who are at ONS last year, you probably, if you came to our booth, you would have seen it. Those black things here are the OLT chips. There's 48 PON ports up the front, 6 40-gate ports. And so 6 40-gig ports, and each of those 40-gig ports is divided into 4 by 10 gig lanes, and each 10 gig lane is dedicated to 1 OLT chip. If you guys have questions, just feel free to interrupt me and ask. Go ahead.
Just to go again about that, so you're saying the OLT chips is dedicated to many like ports and from.
So 1 OLT chip, there's 12 OLT chips, right? Each OLT chip controls 4 PON ports, right? And each OLT chip has a dedicated 10 gig lane, well, has a dedicated primary 10 gig lane and a backup 10 gig lane for dual lane. Did you get that? Cool. Okay. Ooh. Okay, so this is our rack that we took to ONS. We have the head nodes up at the top, compute nodes spread around, OLTs. So we have 1 OLT at the bottom, another OLT which is just a development kit of the 1U OLT that I just showed you. It's the same OLT, same chip, just a development board for it. And then we have a few OLTs which you can't see at all because the contrast is not very good, but they're there. And then a bunch of fabric switches running here, and at the bottom. Okay. So the way we look at Cord is that we have a Cord pod and we draw a line around it. We have what we call a controller where all your API, all the REST API for Cord is available. That's how you would control Cord from. So you could, design your services and execute them against that API. And so your services could be inventory, customer accounts, analytics, allocation policies, whatever you need, whatever you can imagine, you can run it there. And then you would hit the controller API, which is essentially the REST API for Exos. And inside of Cord, we have what we call a service graph. So this is a service graph for our Cord, for residential Cord, where we have the residential subscribers connected to a VoLT. They go then connect through a VSG, optionally get content from a virtual CDN, or egress the network via a virtual router. So you see the color coding here. Some services are blue, other ones are red. The difference between the two is that the blue service is essentially a control plane service. So it's a service that is implemented by ONOS. Whereas the red services are data plane services which only have a data plane element and no control element inside of ONOS. And then we have, of course, OpenStack, ONOS, and some monitoring as well.
Sorry,
Yes.
can I interrupt?
Sure.
I have a question. Question for clarification about the statements of OpenGPON card.
That means that you open the kind of protocol, for example, that is running between the GPON OLT card and the virtual CPU, for example, which is within the core IT infrastructure. Or
We have, you're saying we have an open protocol between the VCP
yes,
and the OLT?
yes, and the open OLT card. It's an open interface.
I mean, between those two, those are data plane connections, so that's just stacked VLANs. Standard Q and Q. Okay. So there's nothing special there. What I think you're looking for is the management interface of the OLT, which is OpenFlow and NetConf, which is, there's actually that, I'll talk about that later, but essentially it's a container running on a compute node somewhere. And there's a protocol between that container and the OLT MAC. And that protocol can be open, but in this case, it's a proprietary protocol made by the vendor. And there's also a protocol between the OLT and the ONT, which is just ONCI. Right? And we're trying to provide an open ONCI implementation as part of this. But that's a longer story.
Ask another question. What do you mean for controller in this context? I find misleading the word controller. Because ONOS is a controller, but used in this context of the service of the slide you had before, I find it a little bit misleading.
It is a little confusing. So the controller, so each service has what we call a service controller, right? And that service controller is usually just an API that you can make calls against. Okay, and so all the services in CORD have an API. These APIs make up the northbound API of XOS. Does that make sense?
Yeah. For the control plane, I understand it's the API or the application you have on top of. For the data plane, the virtual service gateway. What is the controller of the virtual service gateway?
Yeah, it's a bit misleading. It's really, the controller there is to be able to spin up other virtual service gateways, right? It can also be to change the parameters of that particular service gateway, right? If you want to do some different type of traffic shaping there, okay? If you want to limit the user's bandwidth to down from 100 to 10 megabits or the other way around, you could do it by that API. It doesn't mean that something is a data plane service that it doesn't need to be configured anymore. It has to be configured somehow. And we expose these APIs, the ones we see useful. After everybody has a different use case, but for us, we've exposed some APIs, not all of them. Some.
Another point that is not clear to me is also related. How you make the chain between the function? If they are on the control plane, some functions on the control plane and some functions on the data plane. This also.
Yeah, it's a very confusing diagram. I agree. But it's hard to represent. So the point is that all these, the traffic flow is all implemented in the data plane. Okay, so everything here happens in the data plane. The VCD and router, it's all on the data plane. It's just that it's controlled by a control plane application. Okay, by an ONOS application. That's the only difference. The realization of that service happens on the data plane. So in Silicon. Okay. Any other questions? Okay. So at a high level. So this is the kind of the software stack of CORD. At the very top we have XOS, and that's where we define our services. No, it's not taking off. So we have XOS at the top. We have where we define our services, so access as a service, internet as a service, CDN as a service, monitoring as a service. These are all services you can define in OS plus whatever you guys could define. And then we have OpenStack and Docker, where we have the implementation of some of these services, so VSG, vCDN, and then ONOS running some applications, so virtual time networking, VTN, the fabric control, multicast control, VoLT, vRouter. And XOS orchestrates both Docker, OpenStack, and ONOS to realize the function that the function of the service graph that you have defined in Cord. So, okay, so this is kind of the canonical representation of a central office. We have a residence where you have a CPE and an ONU, and then an OLT, Ethernet aggregation, BNG, and some upstream network. So in Cord, the idea is not to just replicate what is done today, but it's also to disaggregate these functions as much as possible. So the CPU, we've lifted its kind of brains out and put it into a VSG in the cloud. The OLT, we've lifted also the intelligence out of it and put it in the VoLT service. For the BNG, we've taken its routing function and put it into the virtual router, and its netting function goes into the VSG, and then its authentication goes into the VoLT. And ultimately, the switching fabric is replaced by the Ethernet aggregation is replaced by our switching fabric. So you see that we've completely disaggregated many of the elements that you would find in a traditional central office. And we'll go through the vRouter, the VSG, the VoLT. We'll talk about those things and how they function. So Cord is not just, you don't run our Cord and then buy a whole set of other equipment and run, M Cord and E Cord. All three cords are designed to be able to run on the same infrastructure. So you have one defined fabric, one set of compute nodes, and you can attach your different types of access to your network, and then you can run R, E, and M Cord on the same infrastructure. And Mark will talk more about E Cord in a second. So we've released our first implementation, our first reference implementation. We call it Creamy Vegetable, and it's a hardware blueprint. So if you go to our wiki, you'll find a bill of materials. You'll find the servers that we support explicitly, the switches that we support exclusively, as well as the OLTs that we support. It'll come with a set of assembly instructions and some testing harnesses. You'll get, as when you download and deploy everything, you get OpenStack, Docker, ONOS, XOS, all working together to achieve the function of Cord. And then you have a set of access services, so R, E, and M. So E and M are not integrated yet. It's the mission. The goal for this release, for the second release of Cord, is to have integrated E and M Cord. Our Cord is more or less integrated, but it requires a few manual steps still working to automate. So one thing that's kind of important to note is Sienna and Radisys are providing commercial support for Cord. So you can go to them and ask them, like, can you build us a pod or whatever it is. So also, if you download Cord today and you want to install it against your hardware, it's really just about 4 or 5 commands to install. You just need to install clone the code, run Gradle fetch, Gradle build, Gradle build images, Gradle publish, and Gradle deploy, and you're done. Right? And if it passes, sometimes it doesn't pass, but most of the time it's been passing. It'll deploy Cord, and all you have to do is boot the compute nodes. It'll provision them all for you. Takes about 2 hours, and then you have a Cord pod. So putting all the pieces that I've talked about together, we have the home residence. We have the home residence here with the Netgear device, which is what we use in our demos, which is basically a Netgear flash with OpenWRT. We have a GPON ONT that connects to the OLT. Then we are in the fabric. We have compute nodes and head nodes, and all this software controlled by XOS is deployed on these compute nodes in spun up. So traffic coming from a subscriber hits the VSG, and then from there can egress through a vRouter or get counted by a virtual CDN. And that's essentially the demo that we've been running at ONS, that we ran at ONS last year. That was also the AT&T trial that's kind of ongoing. So, any questions up now?
Second trial. To the extent.
Hello. To the extent that you can disclose this, can you provide more information about the AT&T trial? We had this conversation some months ago. You were saying, "Oh, it's a small trial," but I don't know if you can share with the floor, with the audience. Well, is it with I know, like traffic-friendly users? How big is it?
It's a small trial and it's friendly users. That's I mean, like that's about all.
But on real services, but just like users, for example.
Yeah, it's users connections, users, but it's friendly traffic. It's basically AT&T employees.
Okay, got it.
We haven't gone past the stage of, and I don't think ON Lab as an entity would want to go any further than that stage, because we're not designed to work in that model. We don't provide support.
Yeah, as a matter of fact, we're talking about Cord, and then AT&T using Cord beyond lab experience and development experience into which of course it's a stage that any operator would do.
Yes, and that's the role of someone like Sienna or Radisys to take on, not ON Lab, because ON Lab is, we're a nonprofit. We barely have 20 engineers running after each other, so it's kind of hard to scale that, and we don't want to deal with the mess of deploying.
Yeah, fair enough. Thank you.
Okay. Any other questions?
Hello?
Yeah.
You have shown the relation between XOS and OpenStack and ONOS. It is necessarily integrated. Could you use any other component that has similar functionality?
Yeah, you could. So the way Cord is designed is that it's separate components that talk to each other via a well-defined API. Okay, that API map, if you will, hasn't been put to paper yet, but I mean, in theory, yes, you could replace any one of those components and put the one you would want in. There's nothing stopping you except a lot of work.
Is it going to come in the next release, this API towards XOS, or?
It'll come eventually. I don't want to say it'll come in the next release, because documenting API and we have about, we did only one release of Cord and we already have 25 different code repositories, right? So for every one of these code repositories, going through them and documenting their API, it's a job of its own, right? So I don't want to commit to that. I would love to, and I would love to get help from the community to do that, but we have other priorities that are more pressing right now, unfortunately. Okay, moving on. Any other questions? No?
Only one comment related to the installation. I'll say we are trying to provide a procedure to completely automate the installation. This sounds good. Sometimes it's not going to work completely, but I think in any way, what we need is also some procedure to reinstall, or grades on specific part. Not the complete installation is something that is good for the very beginning, but is not the way to go, because normally you need to customize what you are also installing, and to change something here and there, and
Yeah,
so a complete procedure you have to change every time, because taking care of all of this.
So yeah, I mean, I completely agree with you. Everything you say makes complete sense to me. There are a lot of parts of Cord that make it not deployable today, for sure. Right? Like for example, the fact that that right now the Cord pod needs an internet connection to be able to be installed. That's not acceptable, right? The fact that like some parts are hard to reinstall and upgrade on their own, right? That's also not acceptable. We've also only done one release of Cord. This is our first release of Cord. Right? So even though the Cord project has existed for about a year, right? It's very different when you actually transition from developing for 1 year and making POCs for a year, and then going and releasing the code. You start from zero again, and start again, right? So this is where we, again, Cord is a huge project. It's gigantic, right? Trying to get all the bells and whistles into Cord is probably more than ON Lab on its own can handle. Right? Keep in mind that we really have about 5 engineers working on Cord. That's about it. That's not very much, right? So we can't get all the bells and whistles, we can't get all the features, we can't get all the things that every single operator wants in. This is why we need people to come and collaborate with us. This is why we need partners, and it's good for you as well, right? Because if you join as collaborators or partners, you then get to drive Cord in the direction that you want it to go. Right? We can't promise you. You tell me I want feature A, I can't tell you you'll get feature A. I can't. I mean, I can't make that promise at all. I won't make it. Okay. All right. So now I'm going to talk about how we do service composition, kind of at a detailed level. So first, it might be worth to define what we mean by a service in Cord. It's a well-defined function with a programmatic API. It has to be scalable, elastic, and resilient. So it scales with a number of users, and it's built out of kind of like self-healing components, and it is implemented as a virtual network. So when you build your service, you kind of provide that auto-scaling function to XOS to describe to XOS how you want this service to scale when the load increases. So that whole thing is a service, right? It's a set of virtual machines interconnected by a virtual network. And then when you want to chain services together, all you need to do is connect these virtual networks together, and you get your service graph. So, like I said, each service operates in their own virtual network. Currently in Cord, these virtual networks are selected using VxLAN overlays. The service can scale both in terms of compute as well as networking. And a bit with detail, but services are designated by their own service ID. So what that means is that for every service in the service chain, when you want to forward traffic to the next service, you just address the next service ID, which is a global IP for that service. And work based off that IP, work as load balanced onto the next service. So let's have a look at a kind of an example. So we have a set of VMs connected to a private virtual network. Let's say it's called the Virtual Service Gateway, the VSG. That connects via, you see that? It says VSG LAN in the local. I don't know if you guys can see that. The contrast is not great. So the VSG service connects through the VSG LAN network to the subscriber. On the other side, it connects through the WAN network to the internet. The VSG itself is connected to the CDN network. And the LAN side is controlled by the VoLT service. The WAN side is controlled by the vRouter service. And then inside, between the CDN and the WAN, there is a caching service that is connected to the WAN side so that you can get content from the internet, as well as serve data back into the VXG and to the subscribers. Okay, so this is an example of how you can interconnect virtual networks to achieve the services that you want and a chain that you want. And it's not a linear chain, because in this case, you can have traffic from the subscribers that goes straight out to the internet, right? Through the LAN, through the LAN network, through the VoLT, through the VSG, through the WAN network and out to the internet, or it can go to the CDN, get its content, whatever Netflix content, and serve it back to the subscriber. So the service chain is not just a linear thing; it's actually a service graph. Okay, so how do we do all this? So we've defined our own virtual tenant network. It basically relies on a single hypervisor switch, which is OVS for now. It's configured through OVS-DB, so when the compute node comes up, ONOS knows about that compute node, connects to the OVS-DB instance on it, and provisions that OVS switch correctly so it's ready for operation within core. I'll show you how that happens. And VTN, VTN ensures that it's correctly configured. And these OVSs, their role is to provide connectivity between the services that are defined in the service graph. So you give XOS a service graph, it says, okay, it takes all the edges of the service graph and creates connections between each service and provisions the rules in OVS to realize that service chain, the service graph. So also, since it's OVS, you can plug, as long as your virtualization technology has the notion of a port that is pluggable into OVS, you can use that in core. So we use OpenStack for two things. Basically, the ability to spin up VMs and to have a networking API that's backed by a database. So that's kind of Neutron. But we don't let Neutron touch the data plane. It doesn't do anything to the data plane. All it does is that it holds the metadata for our networks. That's all. And actually, we're decoupling this as much as we can from OpenStack, because in some cases, we've had feedback that people don't want to use OpenStack at all. And so we're trying to decouple it as much as possible so we can take out OpenStack. So what happens is XOS instructs Neutron, VTN and the VoLT about a new network. The XOS defines the dependencies between these two services, which is essentially the edge of the service graph. So when Neutron is configured with a new network, nothing happens on the data plane. Nothing happens, no action is taken, we just wait. As soon as a VM or a container is plugged into OVS, then ONOS realizes, hey, there's a new port on this switch. And then VTN will go off and ask Neutron, hey, what's this port about? Which virtual network is it part of? What are we going to do to configure it? And the reason why we implemented this that way is to guarantee that there's only a single point of truth about networking information, which is stored in the Neutron database. That's the only place where there's networking configuration. And if ONOS goes down, well, we just have to go back to Neutron and ask Neutron about this information. If Neutron goes down, well, it's a MySQL database. We bring back up the database. The configuration should still be there, and that's okay. If XOS goes down, well, it already told Neutron about that configuration. So there's no place where we have to sync states about the network, which is bad. If you have two places about where there's a networking state, and these things get out of state, if these two get out of state, then you don't know what's happening anymore. And you don't know how to back out of it either, because you don't know who was right. So it's just easier to maintain single location of truth. So, I'll skip this slide. This is basically walking through every single operation when a port is added to OVX, but we're running kind of short on time, so I'm going to skip them. So let's move on to ONOS-based services. So there's the VOLT and the vRouter, and I'll talk about how these are implemented. Any questions before I move on?
I think within your plans were to integrate the whole OVX into ONOS. I don't know if you still have that plans in order to have virtualization of networks.
So the idea would be to first port OVX to ONOS.
Yeah.
Then replace VTN with OVX running inside of ONOS. So that's a ways down the road. Which, by the way, there is a virtualization. If you guys are aware of the brigades that I think William will talk about later on, we have a virtualization brigade where we're trying to port OVX to ONOS. And so whoever's interested, please reach out to me so that we can build that brigade.
Basically, the question now is, looking at that, I have the idea, could we extract this part of the OVSDB plus the Neutron and so on to offer virtualization with ONOS without all the core network?
Yeah, absolutely. I mean, the idea is if we build this virtualization, if you just take out so VTN, the core VTN on its own, you can still use it on its own. Probably not the best. There's other projects that are similar to it that are probably more applicable. Yeah. Like Sona and OpenStack networking and stuff like that are part of ONOS that are more applicable to using them on their own. Core VTN is a bit of a special case for VTN for core. Anyway, no worries. Okay, so let's talk about ONOS-based services. So we have the VOLT service, the first one. Somehow my slides got garbled. Oh, so the VOLT software is an agent that runs in a container or a VM, and basically what it does is that it exposes an OpenFlow interface north to ONOS and an ONCI/proprietary protocol between its southbound and the OLT. So the ONCI part is used to talk to the ONU, and the proprietary protocol is used to talk to the OLT directly. It basically it allows us to provision services on flows on the device, as well as send us 802.1x packets to ONOS as well and IGMP packets to be able to do authentication and IGMP snipping. What actually happens when you boot up your CPE in ONOS in CORD? So a home user reboots or boots up the CPE. An authentication packet is generated and sent up to hits the OLT and is sent up to ONOS. That basically ONOS receives that 802.1x packets and proxies it with a Radius server. And if the authentication is successful, we get back the user's profile. That user's profile contains, how fast of an internet connection he has. Does he have TV? Does he have voice over IP? And we use that information to provision an OLT. Okay. The OLT he's connected to, and we provision it with 2 queue tags. So, we'll say in a second. And we provision the OLT, and then traffic can start flowing from the home user into the central office. So we have the home network, the CPE, the OLT, and then we have 2 Q and Q tags. What happens next, right? So we've managed to get traffic. We've managed to get traffic all the way to that point. What happens next, right? So we have the S tag, which identifies the OLT the customer is connected to. The C tag, which identifies the customer. The OLT has several other functions, meters to meter the customer's connection, group information for multicast. But what happens after we egress from the OLT? So let's have a look. The VOLT app says, okay, now there's a new user, he's authenticated, right? So it pings XOS and tells them, hey, there's a new user, you want to spin up a VSG for him. So we tell OpenStack, hey, give us a new VSG. It gives us a new VSG, and we tell the fabric, hey, there's a new VSG here. You want to take these two Q and Q tags and cross connect them into the VSG. And at that moment on, traffic can flow from the VSG into services or out to the internet and back in. Okay. Any questions? So let's talk about the vRouter service. So the vRouter is really the interface between a cord pod and the upstream network. So, and as such, it implements, we've implemented support for BGP and OSPF. So your particular deployment may vary. So that's a place where you have to put in your own changes. But basically, we have support for BGP and OSPF. So when you hear the term vRouter, you might have thought that like we've taken a mean old router and taken its control plane out, put it in a VM, and declared victory. Right? That's not at all what we're doing. We're not doing that at all. Nowhere close. And the reason is simple. If you have a bunch of VNFs and they're trying to talk out to the internet, and you have a single VM implementing the function of a router, you have to hairpin all your traffic through that VM, and that obviously doesn't scale. So you would say, well, then we just have a whole bunch of these VNFs and we just route traffic through them. But which one do you route through, and how do you handle traffic coming back to you? It becomes a mess, right? This is not at all what we've done. Instead, what we've done is we have the router is the leaf spine fabric, and we have the vRouter app provision the white box switches with the right rules to perform that routing function. And so what happens is the upstream network that we peer against, we peer with BGP and OSPF, and we send that to Quagga. Quagga informs the vRouter and the underlay about the peering information and provisions it back down to all the switches in the network. Okay? So essentially, what we've done is we've built a large distributed virtual router. Okay? So the spine switches at the top are essentially your backplane. Your leaf switches are your line cards that you would shove into your normal CRS router or whatever. And so the advantage of this is if you need more routing capacities, you can just slide in a new white box switch, and you have extra routing capacity, more ports to route through, which is pretty powerful as a concept and very, very cheap and cost effective. So really the router in cord, the main takeaway here, the router in cord is the leaf spine fabric. It's no longer, we don't have a dedicated buffer. The leaf spine fabric is the router. So as a summary, cord provides cloud economies and agility. You can exploit microservices, disaggregation, SDN. We're trying to push the ecosystem towards that. And we have 2 partners providing support and integration. And with that, I'm done. Questions?
Question for clarification about the service model. Do you, in this use case, you implemented the PP operator service model, or is IP DHCP?
IP DHCP. Oh, we don't support PP OEA.
Thank you.
Can you repeat what is doing the router? So it is importing in each leaf or the route,
all the route information.
From all the route is learned from the Quagga, and importing the Quagga also the internal route or no?
Internal routes of internally?
Yeah, or the VSG.
So that's exported. That's exported from Quagga, from the local Quagga. the local clock has.
So in each leaf, I should have all the route that are learned from the Quagga and outside the route.
Yes, and basically that allows you to simply scale your routing as you see fit.
Yes, I guess the question was the first one I made in my presentation. So how about a multi-operator scenario? Should we be able to offer a separated virtual OLT and virtual router to every service provider so that everybody sees, let me say, its own part of the router, but as if he was the only user of the router? And I mean, of course, I presume that, well, probably AT&T and the other guys that you mentioned are not very much interested in that. So, well, I mean, you tell me, I mean, have you thought about that?
Yeah, well, we've thought about it. We've talked about it very slightly, but we haven't gone as far as to how to do it. So there's the idea would be to provide a slicing function in core, where you can slice parts of the networks and kind of resell it. But these are all nice words, right? You know, first, network slicing is not the simplest thing in the world, and depending on what you slice on, it gets very, very complicated. So yes, we've thought about it. We're probably going to start at some point implementing prototypes where we have a slicing function in, but it's very much exploratory to see how we could do them. So the idea is to use network slicing. You could imagine a scenario where you have OLTs dedicated per service provider, or shared across service providers, and then provide virtual networks that connect for each different service provider. You could do that. It's more of a it depends how you cut the pie, right? Like it's not totally straightforward. It would require a kind of like careful deployment and orchestration to get that right. It should be more resilient, but yeah, we haven't gone down that path yet. There's a lot more to do in core.
Just a question. I had actually two questions. One is, how much is the amount of the state in the local environment or in the central part of the code? Second question is, typically at home, I configure things like port forwarding in my router, which led me to understand the virtual router can be configured by two entities at the same time, or you should go through a service through the provider so that you have a different interface to the router. Essentially, the router is controlled by the management, and then it receives requests for.
So let me take your second question first. The user doesn't get to configure the virtual router. He gets to configure the virtual service gateway, which does nothing, which is the equivalent of your CPE today. Right? It's also unclear to me whether how many normal users, let's put it that way, configure port forwarding.
For peer-to-peer a lot.
Yeah, for peer-to-peer.
Exactly.
And even
this is why I choose this question, because it may come out something like that. And if everyone wants to have a specific application configured, then it's
you want to think of
where is the boundary of the control between.
So you want to think of, I mean, you can expose low-level functions like port forwarding and stuff like that, or you can expose higher-order ones. It depends how you want to do it, and you can still, at the end of the day, it doesn't matter what the function is, right? Someone will write an app to provide port forwarding, right? It might just be called, peer-to-peer, right? And someone will provide that, and then you can purchase it and install it, and it'll do the thing. That's the idea. That's the model that we want to move towards. It's more of like, I want to install apps on what looks like my home network to get certain features. Right? I want a personal network that follows me around. Right? Well, I can do that, right? Because just at the end of the day, then it's just software. And your first question was
about where is the data because I think that is there any data part which is in the local premise instead of the central office? I mean, usually what I'm What I'm always worried is what are the data that the network needs to read to work. And usually, as you said, if you have a network which has a lot of data spread around, or is data where there's state in the network, then this is an issue. I don't know enough, sorry for that, to understand exactly where the data is. So how much, if you want, code is state aware?
How much of the code is state aware? Good question.
A lot of code is reliable, that is fine.
Sure.
So I understand that central office is reliable, no problem on the data there. But things get a little bit more complex when you have long links and you have to build things, and so you have to put explicitly data there.
So are you referring to like remote locations that are outside the central office? So the design, that's a feature or a use case that we haven't. It's not we've thought about it and we have an answer for it. We haven't actually tested it. As you can imagine, it's hard to test these things because it's hard to get them right. But the idea is that if you have an OLT in a remote premise, right, the only state that OLT has is its forwarding host. That's it. Nothing more, nothing less. Right. ONOS is still running in the central office. Actually, the requirement that I kind of have for this is that there is no compute in the remote location. Right. At the very extreme case, there's no compute. Any other questions? No. Any other questions?
Why do you prefer this solution with only remote OLT, not any bunch of servers?
Sorry?
In principle, you can imagine that one of the cabinet can be advertising another central office.
Yeah, I mean that's the idea is that like you can have remote locations which don't have compute and connect.
I also compute there.
I mean you can if you want to, right? But in the worst case, if you support the mode with no compute, then you support the case with compute, right? Because it's just in the first case the compute was that the compute was further away. Right? If you bring it closer, same problem, same model, doesn't change anything.
Keep the fabric in central location and one leaf and
that's fine. There's a question over there somewhere.
Thanks. So a bit more generic question, as we talked about some of the, say, specific applications and use cases. Definitely the system is extensible. Some things also change over the releases and as it evolves. And I mean, congratulations first of all for its sort of at this point is already, I think, quite well advanced. So for first release. Question then, how are decisions being reached on the further evolution? How are they taken and how transparent is this? Is that, for example, a mailing list or something where some of the design decisions are being discussed?
Yes.
So take one example, like changing a database system from Cassandra to another one. Or,
yeah. So there's a mailing list. There's cord dev and cord discuss, right? Where a lot of discussions happen. There's also Slack, where a lot of discussions happen, which I don't like, but I can't help it. I don't like it because it's Slack, it's not archivable. So once you've had that conversation, it disappears into Slack systems, and you have to pay them a lot of money to get it out. So it's useless, right? For an open source project, it's useless because you don't have it archived, no one can search through it. So, but all these decisions happen. Then you have mailing lists, Slack where discussions happen, and then there's a TST where you can submit, you can send emails to TST. We have weekly meetings on Mondays at 10 p.m. Pacific time, which is I guess 7 p.m. here. It's not great, but it could be worse. And where you can, it's an open meeting, you can attend, and then we have our sprint planning sessions and our sprint end of sprint sessions, which are also open and you can attend. They're not the most exciting meetings in the world, but they're there, and you can attend and you can talk and you can exchange ideas. So we try to be as transparent as possible. Now, whether we're perfect at this, I have no idea.
Thanks. So that's not different than to any other open source.
It's really, we try to lead it as any other open source project. We try to do it as well as we can. I'm not sure we're doing a great job. It's the birth of an open source project is a very confusing thing.
Thanks.
Okay. Thank you.
Hello, good afternoon. For those that don't know me, I'm Mark Lienier. I'm with the Open Networking Lab with Ali, and I guess a few other of you here have at least visited us or spent some time with us. So what I'd like to do today is, first of all, a quick time check. I'm supposed to finish in about half an hour, right? Is that still the case? Or can I take a little bit more time, because we have, have a little bit, well, some material to cover, and so please tell me if I go too fast or too slow. I will try to adapt. So I guess some background on this. When we started talking about CORD, central office re-architected as data center, the discussion quickly crystallized around how to support residential customers. There was a clear drive to do this disaggregation of OLTs, a clear drive to figure out, okay, what are the services that residential customers care about? So we, around the BNG that turns into the service gateway, how to support multicast and so on. But then, based on discussions we've had with basically all our service provider partners, we quickly realized that, okay, if we want CORD to be successful, we need to be able to support many different kinds of customers, many different kinds of services on the same platform, right? And when we talked some more, it turns out that there's really two broad areas that we started to focus on in addition to the residential work. And one is the enterprise customer, where actually this morning was pleasantly surprised. People were asking questions of what do you do when you have multiple CORD sites to manage? How do you interconnect those? That's really what this is about, right? Later on, I won't be handling this personally. We'll talk you through mobile CORD is our solution of how to build the 5G networks of the future, how to support mobile customers on that same platform using ideas of virtualization, disaggregation, and so on. Okay, so let me spend 1 minute or 2 minutes to talk to you about what is the typical state of the art, how are things done in service provider network. Is there a pointer, by the way? No? Okay. Okay, so what you see here is a typical, say, metro network, right? With a bunch of enterprise locations, a branch office, regional HQ, and so on and so on. For no particular reason, we show this as a ROADM network. Obviously, ROADM technology is very popular in metro area networks, but it does not necessarily have to be. And then, so what happens is, these requests come in of, hey, I have this branch office, I want to connect to my HQ. And I require some kind of SLA, some kind of guarantees about my connectivity. And then you have these typical connectivity options in ELAN, which is a kind of layer 2 VPN, right? It comes in many different forms. There's ELAN, there's an ELAN if you want a network that spans in E3. You can also think of layer 3 VPNs, many different technology options available there. But then it turns out there's a few problems with that in this mode of operation. First of all, and this is to the frustration of the enterprise customers, it takes quite a lot of time to set these things up. There's some manual control, there's some some manual mapping and so on. This takes days, weeks, maybe even months. Of course, I mean, I can't change some of the physics or the reality in this work. Sometimes it's just because there's no fiber into the office building, and someone needs to dig a trench and lay the fiber. That I'm not going to solve. But the provisioning process, that is something I think we can contribute to. The second particularly nasty problem is, Ali alluded to it. When you want to offer these services, you need pretty expensive proprietary vertically integrated equipment, right? And every vendor comes along with its own solution, and brings a lot of capex and especially opex to the central office operations. Now, then from the enterprise customer point of view, it's for him typically very difficult to understand what's going on with his connection. It's kind of a binary decision: does it work or doesn't it work? Right? He has very little influence over, I want to reconfigure certain pieces. I want to test the latency of my connection on different segments. What is the real problem? He has no idea. All he can do is pick up his phone and tell the service provider there's something wrong. Can you please fix it? A final problem that I'd like to point out, and that's, I believe, the biggest one going forward, is this is just connectivity, right? This does not go beyond that. How can we add value-added services? How can we spawn on-demand VNFs? Right? So what our enterprise is doing today, they use over the top. They go to Amazon, they go to Microsoft Azure to run various services in the public cloud. Of course, this brings problems with latency and so on and so on. But it's from a different perspective, it's a hugely missed opportunity for the service provider to sell or to integrate these value-added services along with the connectivity solutions. So that's kind of the context that we're working in with Enterprise Core. So what do we propose? What do we suggest we do about it? There's really three kind of features I want to offer with the Enterprise Core platform. First of all, and I think I mentioned this quite a few times, the connectivity. Giving enterprise the capability to do virtual networks as a service, to create the networks on demand, right? And this, touches on many different things. We'll in next couple of slides, I'll go deeper into the various, implementation issues, the various design choices we need to make to get them. Then the second one is actually the one on the right, is how do we add these VNFs? How do we add these value-added services? Again, why do we want to do this? We want to give the service provider the opportunity to bundle these kind of services, and it alleviates, it lightens the load on the enterprise IT department, because they don't have to run the firewall anymore. They don't have to, run this infrastructure and run all this configuration. And then finally, and in one of the talks this was alluded to as well, is especially for enterprise customers, it's critical to understand the health and the status of their networks, right? So we want to get the analytics integrated right from the start, right? So you can test, you can actively probe in order to observe your network infrastructure, in order to control, and then to kind of close the feedback loop to adapt to certain situations. Okay, and then the big picture here. Wants or implies that we want to offer all of these services using the core platform, which Ali reviewed it in detail. For me, I can summarize it in two words or in two concepts. One is the open source software, the use of open source software for the network plumbing. We use ONOS. For the service orchestration, we use XOS, along with the use of white box hardware, commodity servers, white box switches, in all its in every possible location. So that spans the access devices, the OLT. It spans the commodity servers and switches. It implies the fabric is built on white box hardware. We even went as far as and tried to disaggregate the optical ROADM side of it, the kind of core edge facing piece of the central office. Okay. Any questions so far? Burning questions? Guess not. So what I want to do now is really remember there's three things: connectivity, value-added services, and integrated analytics. First, I'll set the context a little broader for these three pieces. And then in the next part of my presentation, I'll dig deeper and talk about implementation issues and so on. So bear with me, this is maybe a little dry or textual representation of the material. Later on, we'll get into more design issues and implementations. So virtual networks as a service, as I mentioned, these kind of fall into two broad categories. You see 3 bullets, but the 2 broad categories are, hey, I want guarantees, or I can live without guarantees, right? The guaranteed ones, layer 2, layer 3 VPN, they're very similar in ID. Obviously, they have very specific features. Layer 2 VPN implies you create broadcast domains, so that may have scaling issues. Layer 3 VPN is much better, but there's much more configuration and much more stuff to take care of. But I think these two are very well understood by everyone here in the room. The last one is really an initiative we just started, really based on a lot of the feedback we got from the service providers. And it kind of, for me at least, it looked contradictory. So what I mean first, to set the stage, SD-WAN, for me at least, means that instead of offering dedicated connections, private connections, you give them the opportunity to get broadband connections from probably multiple operators, combine all of those with an intelligent CPE. And in doing so, you don't get any strong guarantees, but because you have this multiplicity in the connections, you'll be able to get some guarantees in terms of reliability. And on top of that, you can, with some intelligent software, you can start actively probing and figuring out how, if I'm on my, say, AT&T connection, I have a very good connectivity to Amazon Web Services, whereas my Comcast connection is much better suited for any other type of connectivity. Let me get back to my original point here, is that the SD-WAN overlay may seem contradictory from a service provider, because obviously, they're in the business of making money. They love to sell you expensive stuff, and that's those layer 2, layer 3 VPN kind of connections. But their point of view really is that, hey, if we want to stay in this game, right, we'd better be able to offer this kind of SD-WAN overlay technology, so at least they remain as a customer with even a lousy broadband connection. Even that is good enough to keep them on board. I'd just like to draw your attention also on the right hand of that slide. There's these kind of overarching goals for every kind of connectivity option that we create, and these kind of boil down to one: it needs to be on demand, obviously. Right? I don't want this long manual pre-provisioning process. No, it needs to be on demand. We've shown POCs where we have a UI, and you drive the virtual network creation in a very quick and efficient way. It needs to support dynamic pre-provisioning. So if you want to upgrade your bandwidth for maybe especially event or permanently, it needs to be able to do that very efficiently. And if the final one is kind of popular way of saying, let's try to make these services as simple as possible to use, right? Okay. By the way, in terms of progress, layer 2 VPN, we've been driving this for a couple of months now. We have a pretty robust carrier Ethernet application that implements basically what MEF has been standardizing and popularizing. Supports E-lines, E-lines, and so on. Layer 3 VPN is a partner of ours who's leading that. SD-WAN overlay is right now, at least in an undefined state, or at least there's no partner driving this work right now. But we really want to get some kind of open source implementation of this SD-WAN overlay going, so people can base their solutions on there. Okay, so remember, connectivity. Second one is value-added services, right? All I do here is list a few popular examples, and I believe no one would argue or disagree with me that these are very popular types of applications for the enterprise space, right? Traffic analysis, active testing, and so on, firewalls, WAN accelerations. And again, we want these things to be on demand, right? Have an API for analytics and some kind of customer interface. The way we've been driving this work so far, so remember, Cord is an open Cord. It's a open source platform. So what we do is we implement, we support or integrate or do the integration efforts for one or two of these example applications in open source, right? So for example, for traffic analysis, we used an open source tool called NTOP. There's, for firewall, we're gonna do pfSense, which is also an open source application. But then, that it doesn't stop there. At that point, we turn towards our partners and our contributors that develop carrier-grade kind of versions of firewalls or WAN accelerators, and approach them with the question: are you willing to integrate your carrier-grading solution into OpenCord? Obviously, we won't be able to distribute that, right? I think that's a very clear and simple statement to make. Okay, so connectivity, value-added services. Third one is the integrated analytics, right? And this follows that typical pattern of a kind of feedback loop: how to observe, how to analyze, and then ultimately control, provided you have something to do, of course. There's many pieces to it. I'm gonna kind of skip this textual description of the problem, and later on I have a bit more visual material to explain you what we really mean with the integrated analytics. Okay, so as promised, we have a kind of overview of what we're all about. Let's talk a bit more about how we're implementing certain things. What do things look like on the data plane and in software and so on. Before I do that, any burning questions? No? Okay, so let's start with the high-level view of the connectivity, right? And you'll quickly notice, there's a couple of things to notice really. There's two or more central offices to control, right? Once you want to connect multiple locations, the chances of them being connected to the same central office are minimal at best, I'd say. So you need to connect multiple central offices along with some kind of transport network. Could be metro, could be something else. Could use various technologies. Could be MPLS enabled, could be ROADM enabled. There's many options here. But the choice we've made in terms of controlling all of that is a hierarchy, right? A hierarchical way of controlling this. Remember, every central office has its own cord controller, right? You have an ONOS running in the central office to do the network plumbing. You have an XOS that understands the service graph on the cord level, right? Ali talked at length about this. What about the higher layer, right? So typically, the way we see this playing out is you have a service portal on that higher layer, on the global level. So, in this particular case, give me a layer 2 VPN, right? That thing gets broken down on the orchestration level, right? And I understand orchestration is a term that nowadays is popular and overloaded at the same time. There's many different projects that are claiming to be the orchestrator or having the right to call himself an orchestrator. Let's leave that in the middle for now. For us, it means you have an understanding of a service that spans end-to-end, that spans multiple sites, right? But that original service gets broken down into multiple configuration actions, essentially. So there's a per site layer 2 VPN configuration on every cord site that is involved in this. So for an ELAN, it's it could I think no, sorry. I may show that, but it could span more than just 2 cord sites. And then there's a connectivity policy where we look at a very abstract level at the transport network to tell them, okay, connect me these 2 points with this kind of SLA. For us, I explicitly don't want to spell out ONOS there. It can be ONOS. We have actually demonstrated this where ONOS was controlling a WDM network, where we're showing IP over WDM. But it could be any pre-existing NMS, any existing transport network solution. And this is a very important point to make, is that that transport network does not, in that kind of sense, it does not need to be a greenfield deployment, right? Once you start rolling out cord pods, you can integrate that with your existing network without having to rip out and replace everything. Okay? So, high level view, right? What if we drill down deeper into the central office, right? And remember, it looks something like this, right? You have your new spine fabric, you have a couple of servers. On the access side, you have your customers, and on the edge side, the other side is your transport-facing equipment. So what happens is, remember, this is per site layer 2 VPN configuration. Remember, Ali had these nice boxes where he showed how a service graph looked like. This is one particular example, right? Where the global level will break down the original request into, hey, I have a subscriber. He needs a forwarding construct. He needs to forward across this central office. And that gets specialized or detailed, refined in a site local service graph. And how does that work? Well, there's really two services that are involved. One is what we call the Ethernet Edge service. The other one is what we call the Transport Edge. Now, let me just see. Okay. So again, what's really important to note here is that services may be implemented in many different ways, right? And I believe it's very important to state that all of these implementation options essentially are data plane enabled options. They're fully in the data plane, right? How do you control them? That's a different story, right? So for example, this Ethernet Edge, we have a couple of options. When we first started out with eCord, we didn't have good grasp on what was available in terms of equipment. So the Ethernet Edge we were using was a software switch, right? CPQD switch, because we could do the metering there, we could do the queue management, set up the flows for do the tagging once the package shows up, these kind of things. But then we quickly figured out, hey, actually, these functions, we can relegate these to the leaf spine fabric themselves. These switches can also support this. This is an activity that we're working on right now, just so to be sure that the packets that come from the enterprise customer do not touch any VMs, basically. The third option is really how it's done today, is where you have a specific box to do the Ethernet Edge function, to do the tagging, to do the metering, do all this fine-grained tagging and metering really at the edge. Very similar situation on the Transport Edge, right? Again, when we started out, we didn't really know what we were doing, so we used a software switch. But now it turns out, hey, we can actually most likely use leaf spine fabric. You could even think of having a dedicated box there, just so we are sure that traffic, end-to-end stays on the data plane. Okay. Yeah, and this gives you more detail of basically what I just told. Okay, so let's talk a little bit more about that transport network. Right? Again, what we've demonstrated, and that's just one particular instance, is where we have a WDM network, a ROADM-enabled network. It's very important, again, to stress that this is not a requirement, right? We look at this purely from a kind of policy perspective. Connect me these 2 points with this SLA and then transport network, you figure it out, right? Again, we can show you how to do it with ONOS, but if you don't like it, if you have something that exists already, then feel free to use that or pursue that. By the way, there's a link down below there which brings you to a demo we did for ONS 2016 that shows you how this whole thing works and how it all fits together. We actually went as far as, I mentioned this before, build this ROADM in a disaggregated way. It had a little bit specialty control was required, but in the end it didn't really it didn't affect the whole metro orchestration point of view. Okay, so let's talk a little bit more about the value-added services, unless there's any questions that need to be handled right now. No? Okay. So again, you have this similar realization that you start with something very simple, right? I have my connectivity service graph. I start with an enterprise subscriber. he passes through a bunch of control applications, right? The edge, the Ethernet edge, transport edge. How do you add services on top of that, right? Again, we envision this to go through service portals and so on, and add, in this particular example, a firewall and a WAN accelerator. Now, I didn't, by the way, choose that example at random. Why? Because I guess the first realization once you're in end-to-end service provisioning is that there are multiple, or there are potentially multiple implementation points for a service, right? So, for example, a firewall, typically you have one implementation point at the ingress, right? But a WAN accelerator needs two, right? You can't compress any traffic if you don't have a source, one at the source and a destination. It's a dual thing, kind of. So that's the first decision, and we've actually made some contribution there on how to do the service placement, and then again it breaks that up into different delegation commands to the different sites, right? I don't want to, I call this delegation. This means there's an API behind it, right? And these are the kind of activities. Defining that API is something that is happening right now. I just don't want to, overload the discussion too much with going into that amount of detail, but yeah, I guess you are aware what this means when I talk about delegation. And so basically what happens is this, the service graph gets expanded, right, on the global level. Essentially, the controller realizes, okay, I need to inject a firewall, I need to inject a WAN accelerator on either, in every service graph, right? And that ultimately leads to the whole process of service activation, service provisioning that Ali was talking about. Just this simple API command will enable Cord to spawn its services, to spawn the VNFs and so on. Service chaining together. So we have the connectivity plus the value added services. Okay. So remember when I said there's different ways of placement of your services? That has to do with the type of service, right? But another angle here is that it may also depend on the kind of weight, if I may call it, or the complexity of the application, right? And so I see three locations in the network where we may be spawning these kind of services. One is on the CPE. Now, remember, Ali was talking about a very simple CPE, and I think that makes a lot of sense for residential customers. They don't want to, the smallest box, lowest power consumption is good enough, right? As long as you can control some of the forwarding from the virtual CPE, you're good to go. In an enterprise location, I mean, I think many people would agree that it might make sense to deliver or use a more capable box there, not just a forwarding device. And so the programmable CPE is kind of, x86 platform or ARM or whatever. That discussion I'd rather have other people consider, but consider just as a programmable CPE that is capable of running some VNFs. And then you'll quickly see, okay, you have three locations. You have a programmable CPE, you have the Cord side, obviously, and then the public cloud, right? Lightweight services can be, a wireless LAN controller, a piece of a firewall. The actual full-blown firewall, I think, should run in central office. And then heavyweight services where you do kind of traffic analytics, maybe some kind of root cause analysis, these kind of things. Those are more data center type of applications where you need more, compute and storage capabilities. Okay. So last point, integrated analytics, right? I don't know if many have heard of this, but so we have the Cord platform. A parallel activity from the very start has been ACORD, Analytics Cord, which deals with understanding what your network is doing, right? Analyzing, controlling it, and possibly reconfiguring it based on your analysis is really what ACORD is focused on. Just as a reminder, the very first demo of ACORD was really the leaf-spine fabric, and there was an application there running under ACORD umbrella. that was looking for elephant flows. And once it detected an elephant flow, it automatically re-provisioned or rerouted the traffic to use a different leaf spine hop, essentially. Okay, so integrated analytics. Again, a quick recap for those that are not familiar with or intimate with the design of ACORD. The way it works is you have this concept of a programmable probe, right? It's essentially a tiny piece of software, I guess, that you can customize or inject in different devices or in different locations on the device, right? So it could be on the traditional, port counters or flow statistics, these kind of things. Could be very low layer, could be on the chipset itself, right? Or it could be on the device level. It can even be on the virtual appliances level, right? On VNF to check, okay, how much memory am I consuming? How much CPU is being consumed? How many threads are being used, and so on for my software. It may also be on the kind of network level, right? But these programmable probes essentially report their status to a kind of centralized analytics platform. That all it does is it can configure those programmable probes. At one point, if I'm not interested, don't send me anything, or only send me the aggregate information. When there's a problem, maybe I want to dig a little deeper, and I will send specialized probes to get a bit more information on to do more detailed analysis of what's going on. And then there's centralized data storage. That's basically what it provides. But on top of that, you can start writing applications, right? That use that observed data. These could be real time, and obviously tread carefully, because once you start analyzing data real time, you could start running into scaling issues with your infrastructure. It could be diagnostics, could be security, to see if there's any DDoS going on or whatever. And once that happens, you can close the control loop. So you can observe, you can control. You can analyze, and then finally you could control. And that's exactly what ACORD demonstrated with that elephant flow, when rerouted using CORD NXOS. Okay, so in terms of these programmable probes, ACORD nowadays comes with quite a few, right? There's quite a few programmable probes. I don't want to review this, but the usual suspects. How is my disk usage? What's the CPU or the virtual CPU is doing, and so on and so on. There's many of these available. But once you tread into the kind of enterprise or end-to-end type of network connectivity and services, there's new probes to design, right? That's one of the ongoing activities. Okay, on Ethernet Edge, how our byte counters are pretty standard, but queue lengths and so on. What's the performance of this and that queuing algorithm? Those are new types of probes that we need to spend some time on. Also end-to-end, right? I'll get to that in a minute. Understanding what happens on the central office level does not give you any insight of how your service as a whole is really performing. Let me give you one example of a site local analytics. And I think this example, let me just see. Okay, deals with a kind of scaling in and out operation. It's very similar to that elephant flow detection, right? Is where you essentially are optimizing your resources, right? By using this kind of a centralized platform where you collect not just networking information, but also your service health and monitor the availability of your service. There's a lot we can learn. Actually, just one more point I wanted to make here is on VOAM. So remember when I was talking about, okay, we're actively engaging software vendors that have carrier-grade solutions for firewalls and so on to integrate their platform with us, with XOS. We're actually doing the same with these companies that create these kind of programmable probes and virtual probing of the network. So there's companies that write, a series of tests that will actively probe a layer 2 VPN to see if you're hitting your SLA targets, the one that was agreed with the service provider. So those kind of programmable probes are also getting integrated with the XOS platform and bring a lot of value, I feel, in terms of understanding what your service is doing and how it's performing. Okay, so yes, just to finish the story here, sorry, I keep on switching forth and back. So what happens here is just a very simple example of on a local site, on a single central office. We can have a kind of local control to do the resource optimization, but also to do, detect potential faults and failures, and identifies the cause and adapt to it, right? At the next level, though, we have to deal with kind of cross-site action. Right? At what point, at what point do you decide to do these kind of things? And again, these are very policy-driven applications that tell you how to do this kind of, or when to take action in terms of service migration in a multi-layer kind of fashion. So one particular example here is a kind of service migration where at one point the local ACORD instance detects the one on the left-hand side here. I have a service, it's not performing very well. Right? Now, obviously, there's a lot of choices to make, and I'm going to be a little bit hand-wavy here of how these choices are made. But that kind of information gets escalated to the top level, to the hierarchy at the top, to understand, is this service transferable? Right? Can I move it somewhere? And if so, can I move it anywhere? Or does it need to be at the other edge of my connection, or does it need to have a specific location? And that's really the kind of activity, the kind of features that we're integrating right now with ACORD, to not just understand what's going on, but to take these kind of cross-site actions. Okay. Okay. So let me take a different angle now and review what are we doing right now in ACORD. How far has this evolved? One particular activity is that we have been coordinating and working with MEF very tightly in order to, we can say, okay, this is the latest and greatest thing, but at some point there are some certain standards that are well understood in the industry. And so we keep on working with MEF to around Presto, NRP, APIs, OpenCS, to make sure we are aligned with the industry at large. Obviously, with a very different perspective from open source implementation versus vendors that bring in their own implementations of these services. And as I said, we've been taking the lead in layer 2 VPN. We've done a lot of work there. We have a pretty stable implementation right now. Obviously, I mean, I don't know if you're familiar with MEF standards, but if you look at just the E-line service definition, that's like a big stack of papers to support. So we might have taken some or simplified some assumptions, but we feel it's in a pretty good state. Obviously, I mean, if you feel pieces are missing and you really need it as a service provider, feel free to contribute some of this back to us. The other activity that we are really focused on right now is the value-added services. So we can only do so much at the OneLab. I think you mentioned it multiple times, we're maybe a handful of engineers, up to 20 that can work on everything at OneLab, and that's not only court related stuff. So there's only so much we can do in adding these value-added services, but it obviously bring a lot of value to the solution as a whole. So engaging the community, engaging these software vendors is a top priority to make, it's a kind of counterintuitive when you talk about an open source project, but it's a necessity to get this thing going. So yeah, I'm going to skip this, but I think William will talk about more of how the contributions work and how people can get engaged with the OneLab and CORD. I have very specific needs, but that does not mean if your expertise does not lie on these, and you can't contribute. That's not at all the case. But I'll let William talk more about that. The final part, and that's also something Ali mentioned. So OpenCord was released. It is the core platform with some support for specific residential devices and services. Next release in 2 to 3 months will include definitely eCord and pieces of mCord, because as I understand it, certain pieces are, as I mentioned before, they have some proprietary pieces in terms of the software, at least, that are hard to bundle with the software platform. Okay, so that's kind of what I had for you today on eCord. If there are no questions, the next thing we'd like to do is play a video on mCord. The reason we're using a video is no one here from OneLab is truly comfortable talking about mCord. It's it takes a lot of expertise to talk about 5G networks, all the different technologies involved there. So I'll let 2 people talk in the video. One is Tom Tofig. He actually works for AT&T, but I don't know if you realize that at the OneLab we have the partners bring in engineering resources or design resources. They're on the payroll of the partner, but they work with us in the lab. So there's Tom Tofik, and then the second speaker is Ping Ping Lin. She is full-time with Open Networking Lab, and she drives many of the technology changes and implementation issues with mobile cord. Okay, thank you very much.
And with that, this is opportunity really to show that how we can open up the interfaces with mobility. And I'm going to tell you why and how we did it, and most of the story that we went through the process of getting this mCord to where it is today. And I also want to show you later on at the end that some of the roadmap and the challenges that we have ahead of us. And I'm going to invite you to come to the breakout session to get all the details in per se. So before we go there, it is no surprise to you that for the past 5 years, our traffic has been increasing tremendously. And I think Al you gave us Al Blackburn of AT&T, showed us some of the challenges that we are facing. And obviously, we have spent a lot of money in mobility, with respect to spectrum, $50 billion or more, and a lot more for the than previous version on LTE, billions of dollars on LTE, basically for the RAN and EPC. With that, I think we ended up with obviously a great network with LTE, but it's kind of a vendor's locked, where we cannot deploy these emerging services on the existing environment. And therefore, we need to think about how do we bring in better efficiency and so on. So with that, let me tell you that what are the challenges that we want to face with going forward with mobility. Obviously, we want to show that some of the inefficiencies of the utilization of the spectrum can be solved. Some of the I would say that suboptimal use of the precious spectrum, inability to customize for various customers, so we have one solution for all, we have one scheduler for all, not being able to personalize the scheduler capabilities, for example, for a specific area or location. And we also want to be able to innovate faster, with evidence from all this critical IoT and massive amount of basically IoT that's coming to the table towards 5G. We want to be able to support some of those specific solutions, including mHealth, gaming, and so on. So mobile infrastructure needs re-architecting. So I think it's given, that pretty much the industry accepts the fact that we need to think about this re-architecting in a much better way, and we want to sort of explore what this re-architecting means. What is it that has to bring to the table? Obviously, we talked about resource optimization, being able to bring the right solution to the right application, right flows, being able to take advantage of some of the real-time spectrum management and exploit different radio technologies that might be out there. And obviously for providing an increased programmability where we want to be able to support customized services, being able to enhance the services by being able to enable programmability at the target, which we don't have today, and provide a platform for much more cost-efficient deployment of these services in terms of an agile way and based on commodity hardware and software, which Cord brings to the table. So with that, so M-Cord should be really a platform maybe for 5G exploration because we know where we are going in terms of the trends and so on. And the trends is obvious. SDN NFV should be at the heart of the 5G. We need virtualization and a disaggregation approach of not only the evolved packet core, but also RAM, and as well as bringing ability to bring these services to the edge of the network, wherever the definition of the edge is in this perspective. And of course, I don't have to dwell on what the core architecture is and all of that. So let's look at the architecture. Spine and leaf right there, and potentially this spine and leaf can be shared with residential or enterprise environment. We went and we brought in some of the best supporter of this M-Cord to the table, and we were able to show that access, for example, BBU with a split architecture model. We use ARM-based environment for the access. In this case, we virtualize that. Then we were able to also visualize the eval packet core functions such as MMEs and serving gateways. And we also wanted to show two things. One is the disaggregation at the eval packet core level as well as the RAN level. So we started really playing around with what can be disaggregated in terms of control and data plane out of the EPC and the RAN functions, and that was the intention. And in addition to that, we said if the edge needs to be based on core environment, we don't want to throw away our LTE infrastructures and the core capabilities that we have in the mobile core. It should be interoperable. So we wanted to showcase that how users can get their services either from the edge or from the core environment. So we brought in the same infrastructure as the core. We showed that some of the control apps of both RAN and EPC can be exposed on the higher level, and how we can also introduce some services at the edge. So you may ask, what does it look like software architecture? I guess this picture looks very familiar in terms of what Larry showed and what everyone else showed. But from our perspective, we just visualized the RAM and eval packet core, and we were able to service chain them and show the results in the same manner. And obviously, we need to show scalability and all of that. So what you see on top around modeling and Tosca approach and all of that is very much the same. Mobility has a little bit more demand on the dynamics of the service chaining and all of that, which we are hoping to talk about this a little bit more at the breakout session, and hopefully Larry will help us with that. So this is what we showed in March, right? We demonstrated this M-Cord, very short, in a short time. I think from November last year until March was only about 5 months, and under Guru's leadership, we wouldn't let us slack off, so we had to really show something very quickly when ONS came to table. So we showed that we had a portal for service providers where they could be in control of their network, and we also enabled an enterprise customer that they can program the network and also bring some sales on demand and working with our partners, which I'm going to mention them soon, how we can bring up dynamically new cells, and how this bringing a new cell means to the self-organizing network sound, which is writing on top of ONOS or M-Cord as an application, how you could potentially discover that and optimize, the radios, for that purpose. So let me move on to give you an example of what this looks like. So we had a single rack. We sort of represented both an edge of the network as well as the core of the network. At the edge, we sort of show we can get service at the edge of the network, kind of a local breakout, where you can imagine a stadium or an edge could be a central office, obviously, or it could be a stadium, or it could be somewhere at the hospitals, where if the customer wants to get the services from locally, then if the service is available, they will go to the eval packet core from control and service perspective. But the option exists that you could also get your service from the core of the network if the service is not available in that sense. So this is the rack that we actually demonstrated at ONS, and these are the collaborators. Thanks to all of them, some of them had to fly in from Japan, some had to work overnight till midnight and during Christmas time and all of that to bring this together. But in a short amount of time, we really wanted to show that solution exists and we can open up the wireless interfaces using this SDN NFT approach. So going forward, I want to sort of show you that we acted like a startup. We had meetings, day and night, and sometimes even on weekends. We even had to get Pimping to help us carry the rack. And I'm going to ask Pimping to come over and maybe tell us what she's doing. So I'll come back and tell you more about the details of it. But the idea here is, Pimping can come over, is really to show that how communities can come together, and because of the community's interest and engagement and the focused effort that we get from ONLab leadership and willingness to take risks, from both our community as well. So go ahead and maybe tell us what's going on.
Yeah, I'm Pimping from ONLab. Today I will briefly introduce the recent progress in the past 3 months from ONS until today. The first good news is Agila.in MCOD. They ported their run slicing functions into ONOS. We ported the run slicing portal into XOS. We also finished the run slicing integration with the MCOD pod. So next time when you look at the MCOD demo again, you will also see the run slicing demo together. The slicing here is based on the UE. The second part we finished is the HSS, and we moved from the HSS emulator to the new one because the MCOD is not just for demo, we are for the production work. So we need the real software. The third part is the sound. From our sound team, AirHop, they upgraded their sound portal those days. And currently, we are working on integration between the sound and the ACOD. This is for the sound team. And the fourth point is the services. We already demoed in the OAS, as you may know, the virtual BPU and the service inside the XOS. We can very easily to bring up a virtual BPU service, just a backlick. Very simple. And so now the virtual packet gateway is also available inside MCOD rack, MCOD pod. And the virtual serving gateway is in progress. Can you move to, yeah, thank you. The fourth point is the fabric integration. The fabric is a very important part of the cloud platform, also very important in the MCOD. For the fabric integration, we finished the part of the work. There are still some components we need more work to finish. Let's take the virtual serving gateway for example. The original design from ACNet Breaker is based on VLAN, and our fabric design is based on VXLAN. So we need a conversion to finish the work before finish the integration. So it needs a little more work. And the last important part is the end-to-end integrate the end-to-end testing to the MCOD pod. Wait a moment. Sorry. For the testing framework and the function testing script, we are already done. And based on CodeHams, the UE emulator equipment. And those days we are working on the automatic testing together with Jenkins. That's all for the briefly introduction. Tom will continue.
Thank you so much. So now you know why I'm saying that. It's great to work at ONLab. With these really great people and really very smart, intelligent, and all that. So let me do some marketing for why you should be at the MCOD breakout session, right? With that is obviously we are working on a lot of great stuff. We have a lot of collaborators, which I'm going to name you next, maybe. With respect to RAN slicing, we are going to have a good presentation from Argela. Hopefully, they're going to give us that. And we have about 8 or 9 sessions, short sessions at breakout session, including Yoon from SK Telecom, which has been very great to work with him. Just going to give a little overview of our MCOD roadmap and what they're trying to achieve next 3 to 4 months. We tried to make it next to 3 to 6 months. It was kind of hard getting past by Guru. So we're going to have to deliver something in October per se. We're going to be talking about both RAN slicing and core slicing, obviously. We're going to be bringing Shrikant from Ericsson into M-Cord if possible, so he can get really some of this analytic works, great work that he's been doing, and show the observability to the picture. We want to also great work from Intel and AT&T on connectionless services. We're hoping to showcase that. And our friend from Verizon, Santia and Patricia, in pushing M-Cord.
Okay, yeah, so we could cut the last part. I think there was more meeting specific talk. So with that, I think we finished the review of Cord. Now you know what the Core platform is, the different use cases.
Can I have some money, please? Is that money in you?
Yes. Okay. So feel free to ask us any question now, or during the coffee break, or whatever. Just the M-Cord ones, we're not really comfortable answering those because we're not that intimate with that. Thank you. Oh yeah. If you want, give me your card, and I can't really see who's talking, but I can get you in touch with the people that will have the answers for you. Okay.
Okay, so I think we can get to the coffee break. Just before going there, I have to make an announcement. I hope we managed, in order to have an easier access tomorrow morning. You should have for that a magic card that Mario has prepared for the purpose that will allow you to enter through the glass door and not the badge pass through on the door. So you enter the same front door, and you don't need to show on at the guardian, but you just have to go through the glass door that will open. There is someone there. Mario has distributed these magic cards that shows that you have already registered today to some of you, not all of registered guests. So those of you that don't have yet this, please go to Mario to get it in order to simplify the access tomorrow. Only the people that are coming tomorrow without being here today will have to do the registration process, the normal registration process tomorrow. So if you know someone, please tell them to be here in advance. Okay, thank you. 15 minutes for the coffee break. Sorry?
Yeah, return
the badge tonight and keep this card just to show
you have your passport back, and then tomorrow you
Mario?
Sì, porto io anche perché non so sul telefono, quindi eventualmente poi chiamo la
Veramente da parlare con Mark che doveva essere a Boston. Per l'intervallo. Yeah, because I don't look at it because I know you have a magic list.
Kind. Okay, are you joining for the dinner tonight or?
My second question. I received a manual with the location. Is it okay if I would join?
Yeah, I think so. So you are joining.
Great.
Number then.
29? Ah, number.
Yes.
Ah.
Very simplified procedure.
Okay. Ah, it's even secure. I guess he has my pass number and wants to see my passport, right? I don't know that we have such high security measures for a normal office building in DT. But okay, it is as it is.
No comment.
Okay, I should not lose this magic number passport sheet of paper.
Yes, let's hope they can do 20% of what is going to be allowed. So my chat with you was that approximately as in case of some 20% from your country. Yeah, Okay, thank you. Are you? Yeah. So, I am more than that. And the first one that is over
Che dici?
Ciao Paolo. Cosa fanno domani? Presentano qualcosa, ci saranno domani. No, ma io se riesco. Sì, però voglio dire, loro fanno. Sì, vabbè, domani.
Una novità,
Avete provato? Scusate, ho separato di te. Infatti che si dice non mi vedo. L'avete chiesto, ma ora cosa fanno?
le persone che invece si sono dati per queste storie si
Possiamo neanche dire, guarda, no,
Ah, quindi era partita da loro, è arrivata solo adesso noi. Tanto siamo leader. C'era Daniele. Leonardo. O Marcheso, faccio venire uno dei due. Ecco lui. Ve lo dico al mio capo per non essere lì.
Diciamo che era stata fatta un'organizzazione con loro, con Cecilia e con il passato è già andato.
At some stage, breaks it open.
Especially on Gmail, my boss was Nicholas he was a lot of
Yes.
Lo facciamo
You're also looking into GPONs and all that stuff, right?
So please, can you take a seat so we start? Can you please take a seat so we can start? So we will try to finish at 5 as it was promised, even if this session will be much shorter than. But if there are any questions that are still open, I think that we'll have time tomorrow to come back to these issues. The whiteboard is still white, so if anybody has questions to be put there for tomorrow, please do that. William.
Thank you. Good afternoon, everyone. My name is William Kubiger. I'm Community Manager at OneLab. So before we begin, I have a few important points. First, I want to thank, on behalf of the OneLab team, of course, you've spoken to me, Mark, Andrea, and myself. So we're very, very grateful for this event. Thank you to Telecom Italia and CreateNet for organizing it. It's co-organizing it. It's really, we're very, very grateful. The second important piece of information is that this presentation is very different from the other presentations. Warning to everyone, I hope it will be good news or maybe it could be bad news, but there will be no diagrams, no leaf spine fabrics. Believe it or not, there will be full sentences with no acronyms inside. Oh, okay, maybe. Maybe I'm exaggerating a little bit.
A little bit of math.
Yes. We'll see. So we've open source, ONOS and CORD being an open source, and behind all open source projects, community. And so ONOS CORD lies a very, very community, and I'm going to be talking to you about our community and our efforts to build, sustain, and grow this community. I had an hour and a half about to talk about this, but because of our dear friends at the registration desk, I have to cut it to 30 minutes. But I had to tweak, I had to change a little bit of the content. We'll be covering some points that I wanted to cover today. We'll be covering it tomorrow during the second community session. So today we'll be covering the following points. I'll provide a very general background. Again, just a refresher on why we do what we do at OneLab. About the community and give you just a brief snapshot of how our community is structured and how we're organized. I'll talk about what the community is creating and the contributions and the ever more diverse set of contributions that we're getting from the four corners of the world. We'll talk briefly about the efforts to grow our community. Andrea will give a little bit of an interlude how everyone in this room can get involved in ONOS CORD if you're not involved already. And last but not least, we'll be talking about the ONOS CORD membership model. If you recall, Paolo had one slide where he had a lot of questions that need some, clearly we need to provide a little bit of clarification on how our membership model works, what's the difference between a partner or a contributor. So hopefully by the end of this presentation, we'll have covered. Of course, we'll have maybe a few minutes for a question and answer. And then there's a dinner tonight, and then we'll also tomorrow we'll have ample time to ask further questions. Okay. So why does OneLab do what it does? And to remind everyone, OneLab is a nonprofit organization. We're based in Menlo Park in California, and we build tools and platforms and open source communities to realize the full potential of SDN. We have 3 guiding principles. We want to improve networking in the interest of the public good. Again, we're a nonprofit organization. We want to fix closed and expensive, inflexible, and very complex. And last but not least, we want to really breathe new oxygen into and encourage innovation rather than. Now, our community is composed of several groups. Is really at the core of the community, and so OneLab, Ali mentioned we're about 22 engineers, maybe a little bit more today, but we basically provide the core engineering focus of ONOS CORD and also architecture shepherding. So we work very closely with partner service providers who, together we identify ONOS CORD solutions that are relevant to service providers. And of course, we work with our partner vendors with whom we identify solutions or deployable solutions to those solutions we identified with providers. And then we have collaborators. So we have 60 plus, maybe 80 plus companies today. We have to maybe update this slide. Organizations, universities that are actively interested in contributing to the project or have impact and push the project forward. And we'll talk a little bit about the differences between partners and collaborators. And then individual volunteers, individuals around the world who are passionate about what we do or for whom our mission really resonates and want to get back and contribute code, but not only code, but can be lots of different ways to get involved. And Andrea will talk more in detail about that. So I mentioned, okay, so we have 22 full-time employees, and this is how our staff is distributed today. And I'll ask my colleagues if there's but in any case, we're more or less 20 plus employees. And you'll notice that we have two, so engineers, except we have two non-engineers. I'm probably one of them. And my colleague David, we form the community team. So two dedicated full-time staff who are focused on supporting and growing our community around the world. David is based in California. He's focused more on internal participation, supporting our internal ONE Lab staff and helping our staff work more volunteers with our contributors. And I'm more external facing. I'm based in Paris, France, actually. I'm the first European employee. Definitely not the last. I'll talk about that in a little bit. And so I'm based in Paris, and I'm traveling more or less, half of the time around the world to support our community. Today we have quite a lot, a growing list of partners, so organizations that are to become official partners of ONE Lab. And as partners, and we'll talk about that later, seat on our board of advisors. As a partner, you can help steer the direction of ONOS and CORD as is relevant to their needs. We have a lot of collaborators. I mentioned we have 60, 70, 80 plus collaborators. We have ONOS collaborators, and we also have CORD collaborators. I won't go through all the list, but of course, have already been mentioned today, and you're very familiar with others. I should have mentioned, so David and myself joined, David joined almost 8-9 months ago. I joined 4 months ago, and since ONE Lab has invested in community, we have seen a very stark uptake in our membership growth. People who have actively joined projects and started contributing. Now, one of the strengths of our community is its diversity, and one of an indicator of success in our community building efforts is really to broaden the contributions coming from the community. And so the red part you'll see in this pie chart here are ONE Lab co-commits that represent, when that slide was made, it was about 42% of co-commits were from ONE Lab, and the rest from a diverse community. And as time goes on, we want that red part to shrink, and we want to welcome new contributors. So diversity is one of the really big focus for David and myself. Now, what is the community creating? So I won't go through this. We're short on time. So here's a little snapshot of contributions for GoldenEye, and you'll see on the right column organizations that have actively participated. Contributions. I will be sharing these slides, actually, as all the slides I mentioned will be shared after the workshop, and so you'll be able to have all the contributions. So this is for Falcon, MU, all these releases, and back to Drake. Now, are we growing community? I'll go over 3 main pillars of activity for the next year. Are focusing first and foremost on engaging and working with partners and collaborators. We are constantly on the road, particularly myself, talking to potential partners and collaborators, organizations who are interested, but maybe need to know a little bit more, need to dig a little bit more before they sign up to as members. The second area of focus is really building our internal capacity. By that, we mean improving the way we work with our community, being more systematic, more transparent, more open. Ali said earlier today that we are difficult work to be a fully open source project. There are some challenges and some and we're always trying to be better. But we're very every morning when we wake up, we want to stay true to our values of openness and transparency. And so it's really a guiding principle. And so we're always improving that. Now, we also want to grow our regional communities. And by that, we have many contributors that around the world that have started to form teams or local regional communities to organize and structure their work as they contribute to ONOS and CORD. And so we're deploying several initiatives, including one which we'll talk about tomorrow, which is the Ambassadors Program, a program that empowers members of the community to be local official ambassadors of ONOS and CORD. And so as ambassadors, they can be for the community. They run activities, hackathons, meetups, that also interface between ON Lab headquarters and our partners and collaborators in different parts of the world. We'll talk about that more tomorrow. And another important initiative in terms of regional community building, and this is an announcement. I wanted to make this announcement earlier today, but everyone was really kind of immersed in the code and in the technical presentations. I didn't want to, be like the needle that scratches off the record and just, kill the energy. But it's a very important announcement. We're organizing a developer conference, our first large-scale developer conference in Paris, November. So it's November 2nd to November 4th. For developers and partners and collaborators. So we'll be giving more information on that. Just a very important point. So the conference is free to students and to people who have contributed to ONOS. So please, if you have questions, I hope you do, come find us, anyone from the ONLAB team, and we'll give you more information on this. So remember, mark it in your calendars, November 2nd to November 4th. Yes, and tomorrow we'll give more details. But sadly, I'm assuming some people in this room might not be with us tomorrow. So I wanted to also focus a little bit on our activities in Europe. So we're actively meeting and discussing with different organizations, service providers, specifically in Europe. Not only service providers, it's in Paris 6, probably some of you might know Guy Pujol and Stefano Secchi. Really doubling down our efforts to engage with our community in Europe. And we're very see a lot of more and growing momentum across Europe. So much so that we're very interested in exploring the possibility of setting up one lab branch in Europe. Where it's going to be, I don't know. Turin is a beautiful city, but it could be in other beautiful cities in Europe, including mine. But more importantly, the idea, the rationale behind setting up a branch in Europe is really to support service providers who would be based in Europe, European service providers who would be interested in partnering with us. Having that close proximity, working in the same time zone would be extremely impactful. Now, the idea is, and again, this is nothing set in stone. This is something that we're actively pursuing, exploring. This branch would have critical mass of engineers, about 8 to 10, as we assess the needs and also, of course, contingent on the service providers that we would be working with. And very importantly, and this is really to touch on some of the questions earlier this morning about how we would operate. If we were to set up an office in Europe, it would really be an extension of our office in Menlo Park, engineering extension. So we would have staff in Europe, but they would basically be working in lockstep, engineers and managers at one lab. So very diverse, like a very healthy mix of vendors, SP engineers, and ON Lab engineers, of course, working together as we're currently doing in Menlo Park. I can't give you exact numbers, but we have some, engineers from AT&T, Wave, different SPs physically in our office. Yeah, sure.
Because there was also a question about coding. And so regarding the code perspective, there would be no difference, meaning that all the code that would be developed in Europe will merge in the same repository as the code that would be developed in one repository for ONOS, one repository for CORD. All the code will go. Meaning that use cases will be at the same place of United States use cases, there will be no difference. There will be one roof in Europe and one roof in the United States, but all the same company, and there will be no difference from a code perspective.
All right, so Andrew, on that note, I'm going to invite Andrea to walk you through a few different contribution pathways that we have for ONOS in CORD.
So, as William said, there's not only the code aspect of ONOS and CORD, but also also a question that was asked before to Ali. There's also documentation and talking about what we do and deploying ONOS and CORD and lot more stuff. We do have a lot of these documents. I'm gonna just fly over a lot of. You can find everything in our wiki pages. That is a pointer. You will receive the slides. So you can go take a look at it. And there's exactly the whole path for you to just discover the thing if you're not familiar with it, do some coding or do some bugs or do some documentation and all that. Since we are an open source project, one of the key points in an open source project is that you come in to scratch your own itch. Phrase that was told some time ago. Meaning that if you have a need and you feel a need for something that is lacking in a project, you come into the project, you download the code, you get your hands dirty with it, implement your own problem, and you solve your own problem through the code. That means two things in ONOS. Basically, one, helping the core team with the roadmap that we do have and join in and help, for example, the intensive system or the virtualization brigade that we talked about before, or the graphic user interface. There's a lot of need. And we're actually implementing the brigade subsystem to help in this matter. And me and William will talk more about that tomorrow. And also you can build your own apps on top of ONOS and contribute back to the ONOS repository because this is very important for us. We develop ONOS in order for people to deploy it and build awesome applications for their own use case on top of it. And this is back for other people to use. Basically, what we will have to do is develop an application, send it to the review process in our Gerrit code base, and slides. Okay. You will go through a review process that we have in place because the code to match a set standard, because we do not want to not high quality. And after that, your application will be merged into the ONOS repository, and everybody can use it. And also, like somebody just submit a small fix because he sees the problem for, like, for example, a port, or he wants to augment a little thing, and that just submit a patch for review on Gerrit. If you have a much bigger to implement, you might want to submit a proposal to TST that has, as Ali mentioned before, this is valid for both ONOS and CORD. It's the same. So TST has weekly meetings where you can discuss your proposal and receive feedback from the core team of engineers. And there you should submit a document. Then a good practice is to submit APIs about what you're telling, or what is your application, or because the API and the code talk a lot, and they can be corrected easily before going into code, into implementing the real code. and enables us to give you early feedback, and you do not burn time on things that will not get accepted on a later stage because they're not good enough. The team with the roadmap, we have a bounty bug, meaning that we have a set of bugs that are known and are there, and you can just take a look at them and decide one that you see fit for your knowledge of ONOS CORD and just fix it. Attend sprint plannings and sprint demo meetings. We usually do 3-4 sprints in an agile fashion. And as we were saying before, virtualization, build infrastructure, internal framework, GUI that we are building. Those applications, as we discussed before, they're part of the platform and they come in the same repository when you download it. So if you bring your own application for your use case, this would be the place where it lives. Regarding documentation is something that we value a lot, but us as developers sometimes lack documentation, will to do documentation. I myself do the same. And so if you feel that a piece is not documented enough, please let us know. And we do have a community call every other Wednesday. And this is just for not only code documentation, but also tutorials and all of that. And if you're really good at writing these kind of documents, please feel free to contact us, and we do have work for you. And there's also bounty bugs for documentation. And since we are an open source project, ONOS released about 1 year and 8 months ago, and Cord just released the first version. We do have a lot of need, and you can also help us shape it. Maybe you have more experience than we do. Another very important thing is that you may have an online presence, or you might be very good at spreading the word about the things that we do. So this is also something that we do want you to help us out. If you go to a conference and maybe you hear a talk about ONOS CORD, just share the word online, because we want to gain momentum, and surely the social media is something that is used to do that. We have a Twitter account, or Facebook page, YouTube. YouTube is something very, very useful because we publish all the TST meetings, both for ONOS CORD. We publish sprint plannings and sprint reviews, and there are demos, there are screencasts where you can learn stuff about ONOS. Offline, we do have the ambassador program, that is meant for people knowledgeable about ONOS CORD that want to share the word about these two awesome projects in their company, in their community, in their university, in their just where they live and where they work. We just rolled out the program, and we started accepting applications about a month and a half ago. And we already have a good number of ambassadors that are spreading the word about ONOS. I myself am one, for example, living in Milan, in Italy. And we do have, well, he's not here, but Michele Santuari from Created is another one. And we encourage you to become one if you want. And something that you could help us do also, we have deployments. We didn't touch up on this morning because there was not enough time, but we do deploy ONOS on research networks. Very good number of deployments that are managed by ONLAB people, but also from the people of that specific research network. And if you're like in a university, you want to deploy ONOS like Creonet in Korea did, you can just take and NCTU also in Taiwan. Just they deployed ONOS in their campus network with SDN IP to do peering with normal IP networks and SDN networks. And this is something that we definitely welcome, because we try ONOS in production, almost production networks, and we receive really a lot of feedback out of it, meaning that we can shape the roadmap through the help we get to deployments and the lessons we learn here. And there's really a lot of stuff. A really important element is that you can help us doing code review, meaning that is really touching, but it's really, really important because we set the bar for the code really high because we want to keep that code at the highest quality possible. So the code review is something that is really important to us. And we did develop a module owner model. So if you, let's say, come in with an application and other people chime in and contribute to your application, and you start doing good code reviews, and the TST picks up your good contribution to the code review, you become a module owner, meaning that you can submit for that piece of code contribution from other people to the ONOS repository without having to wait for TST members to approve that. And please, we do have a lot of mailing lists, ONOS Discuss, ONOS Dev, Core Discuss, Core Dev, where you can just bring your ideas, share it with us, and let us know what you think. And regarding community, if you're not that technical, but more of a community guy and a high-level guy, please do join our community steering team. It's held every 2 other weeks, just like the other meetings about community, and help us build it, because we are shaping the community right now. We just started. We are growing at an awesome pace, but your help is really, really needed and welcome, and we do appreciate it. I guess with that, I'll give the presentation back to
you.
Yes, please, go ahead.
Andrea, you said us that what you told is valid for CORD and ONOS.
Yes.
That means that also the XOX, the orchestrator part, is embedded in this stuff, or is outside of the scope and maybe is implemented by another kind of community?
No.
The complement.
Emphasize that, please. Just William flied on this, but I can point you up to something. Okay, so you see the 5 core employees that Theo, Larry, and Scott and Charles. Basically, Andy and Scott are XOS people that develop XOS. So XOS is part of CORD. You want to do something in XOS, it's in the CORD community. You just send an email to the CORD Discuss or CORD TST and saying, oh, I want to build this awesome feature in XOS. You can do that, and it's part of all of this. Okay? And Ali can give you more insight into that if you want an offline discussion.
Any other questions for Andrea? So a quick show of hands, how many people after this presentation who have not yet contributed to ONOS CORD will be exploring and ways to contribute? Okay, small hand here, small hand here.
Good. ONOS CORD, whatever you feel like. Thanks, everyone.
So we will close by talking a little bit about the membership model that we referred to earlier. And hopefully this will provide some clarity on terms of what we mean by member and what are the different tiers of membership for ON Lab. And if you work for an organization, a university, vendor, service provider, anything, please, hopefully you can, this will be helpful, and we'll be around today and tomorrow to answer further questions and, and start a conversation about joining if you're interested in becoming a member. So as I mentioned, we have a tiered membership model where we have individual members, collaborators, and partners. Very important point to stress is that we open membership to everyone and anyone. Anyone can join as a member. We are open source and we will remain so. Now, individual contributors are members. Basically, there's a simple form you fill out on our websites. And I'm going to specify that the annual cost, development commitment, test, and proof of concept commitment are because you'll see they differ by membership type. But as an individual, it's of course absolutely free, and there's absolutely no development commitment or test or POC commitment as an individual. Now, as a collaborator, collaborators are organizations that are interested in contributing and helping our community grow, contributing to our code base, and really pushing ONOS and CORD forward. And so many of you in the room are part of organizations that are collaborators. As a collaborator, there's no annual fee, there's no development commitment, and there's no test and POC commitment. But when you join as a collaborator, there is a process that you need to follow where you send a proposal of a project that you would like to focus on that is either relevant to ONOS or CORD, and which is reviewed by our technical steering team, TST, and if approved, then you officially become a collaborator. The logo of your organization is displayed on our website. And basically, as a collaborator, you commit to working on the project that for which you send a proposal. And ON Lab will work with you and support you to make that project a reality.
Another example.
Yeah, go ahead.
Another example of collaborators are the guys that deploy ONOS and CORD in their universities. So it's not only about the code, but it can be about deployments. For example, NCQ is a collaborator, and because they deploy ONOS in their university, for example.
Right. So typically, and I say typically because there are some exceptions, but typically collaborators are nonprofits, research institutions, academic institutions. But we also have, recently we announced that Telefonica became a collaborator. And so Telefonica is working both on ONOS and CORD. And so they submitted a proposal and that was reviewed by our TST. So we announced Telefonica as a collaborator. Now, this brings up a very important point, which goes back to the earlier questions that Paulo shared this morning, that when you join as a collaborator, you can focus on ONOS, or you can focus on CORD, or you can focus on both projects. In the case of Telefonica, they're a collaborator on both projects, but there are of course some organizations that are choose to focus on one specific project. Now that's different from the partner model, and this is the last slide. Partners are basically have paid to have a seat on the board of advisors of ON Lab, and as such, partners help participate in discussions that steer the direction of ONOS and CORD in a way that is relevant to them. So this is a very, very important distinction between the collaborative model and the partner model. Partners are actively involved in the high-level discussions and decisions of where ONOS and CORD are headed. Now, this has an annual cost of $500,000. There is a development commitment of 2 engineers. And so I mentioned different organizations that have their engineers in our office in Menlo Park. And then there's a commitment for 1 test or 1 proof of concept. So I mentioned we have about a dozen partners, service providers, and vendors. And just last month, we announced Google, and Ali mentioned this, Google, Samsung, and Radisys are our latest partners who have signed up. And so we've just updated the website, so you'll see the latest list of partners and collaborators. So there's more detail. Of course, I won't go through the whole process of becoming a partner in this presentation. As I said, I'll be around to provide more granular information. And I really want to just repeat and stress that when you're as a partner, This is different from being a collaborator. When you are a partner, there is you are basically on the board of advisors and participating in discussions around ONOS and CORD. So we don't have specifically CORD partners or specifically ONOS partners. At least we don't articulate that on the website, which is why, and I think there was a little bit of a lack of clarity around that point. So just wanted to make that clear. And yesterday, so my colleague David Boswell just updated the website. So to make it more explicit that the process to become a partner is exactly the same for if your organization is particularly interested in CORD or particularly interested in ONOS. The fee is the same, the process is the same. There. All right, so we're at time, which is, yes, so this is questions. You have to wait for the slide.
Back. You can come back on the slide, please. About the two engineer commitment. So my understanding is, if my company wants to become partner, I've got to have 2 full-time employees of my company, which are paid by my company, and they can sit in your company.
Organization.
Under your roof, yeah.
Yeah, yes.
Okay. I understood that, up to now, my understanding was that that ONLab would employ actually 2 developers working on the project that my company is proposing, but obviously I was wrong.
So we do allocate, and I guess I'll invite Ali and Mark, if they've been around much longer. We do allocate engineering resources to support and to work with our partners.
But we don't. I mean, it's not like it was $500,000.
No, wait. I'm sorry. Okay, thank you.
So it's not like if you give us $500,000 and then we go off and hire 2 people with that $500,000. No, I need to get paid too.
So that's why. So no, but that's a good question. That's why we do. When I said we allocate resources, so Ali is going to work with your 2 engineers to realize the project, the specific project you have.
I think the way you want to look at this, right, is that you get to sit on the board of directors and make high-level decisions about CORD or ONOS or both. But that's very well and nice, right? So you say we want virtualization, but if no one is there to actually build the virtualization, then it doesn't really help, right? So by deciding what our priorities and actually putting people on it, right, you get to steer the project in the direction you see fit. And now the second point is you don't have to have 2 engineers sit in ONLab. It's recommended that they come for a while so that they get to know the people. They can sit back in wherever you want to sit. But that's not a requirement that they be physically co-located at ONLab, and we don't have enough space for everybody either. So that's not really a big issue. But having 2 engineers working on ONOS or CORD is probably the thing that you actually want, if you're going to go down this route of a partnership.
No, okay, I mean, I wanted this clarification because I'm not the only one who has understood this.
Sure. Okay.
At least
yeah, that's why. Well, that's a good question. That's why I was hoping that these slides would provide a little bit more clarification on our model. Any other questions? It's been a long day. Okay. Well, thank you all very much, and hope to see many of you, if not most of you, tomorrow for the second piece of our community session. Thank you.
So we have done. If there is any question, we are here until the closing of the controlling, and see you tomorrow.